What if everything you have heard about 3I Atlas is only half the story? You have seen the headlines, you have heard the debate, natural comet, alien technology, too big, too fast, too strange. But here's the question nobody is answering cleanly. What does the actual data say? Not the speculation, not the dismissals, not the media coverage that picks one side and runs with it. The real numbers, the real chemistry, the real trajectory math, and the real reason why some of the most credentialed scientists in the world are still not satisfied with the standard explanation. On July 1st, 2025, a telescope in Chile picked up something moving across the sky. The astronomers who first looked at the data ran the numbers twice. Then they ran them again, because what they were seeing did not make sense under any normal explanation. The object was moving too fast. Its path was wrong. It was not looping around the sun the way every planet, asteroid, and comet in our solar system does. It was cutting straight through, from somewhere else. By the end of this documentary, you are going to have the full picture, every major anomaly, every piece of evidence, and every honest answer the science can currently give you. Subscribe to Space Aquarius, and let's begin. To understand why 3I Atlas matters, you first need to understand what it is and where it came from. The name breaks down simply. 3I means it is the third interstellar object ever confirmed to be passing through our solar system. ATLAS stands for Asteroid Terrestrial Impact Last Alert System, the NASA-funded telescope network that first detected it, operating out of a facility in Rio Hurtado, Chile. The first interstellar visitor was Oumuamua, detected in 2017. It was small, fast, and deeply strange. A cigar-shaped object with no visible coma, no tail, and an unexplained acceleration that defied simple gravitational models. The second was 2I Borisov, detected in 2019. It looked much more like a normal comet. It had a coma, a tail, and chemical signatures consistent with solar system comets. Scientists breathed a collective sigh of relief. Maybe Oumuamua was the weird one. Maybe interstellar objects were mostly normal. Then came 3I Atlas. And it was neither. It was bigger than both of its predecessors, faster than both, more chemically complex than both. And it displayed a combination of features that did not fit neatly into either the weird like Oumuamua or normal like Borisov categories. It was something new. When astronomers first calculated the orbital parameters of 3I Atlas, several things stood out immediately. First, its speed. 3I Atlas was traveling at approximately 58 kilometers per second relative to the Sun. That is roughly 130,000 miles per hour. For comparison, Earth orbits the Sun at about 67,000 miles per hour. Voyager 1, the fastest human-made object ever launched, is currently traveling at about 38,000 miles per hour relative to the Sun. 3I Atlas was moving at more than 3 times the speed of our fastest spacecraft. Second, its trajectory. The object's path was hyperbolic, meaning it was not gravitationally bound to our Sun. It was just passing through, on a one-way trip from somewhere else in the galaxy. Third, its size. Early estimates based on how bright it appeared in telescope images suggested the nucleus could be as large as 20 kilometers, roughly 12 miles across. That would make it far larger than either Oumuamua or Borisov. And it would create a serious problem for the standard models of how many interstellar objects should exist. Because an object that large arriving in our solar system implies a source population of interstellar objects so enormous that the numbers strain credibility. That was the first anomaly. It would not be the last. Within days of the discovery, Avi Loeb, Harvard astrophysicist, former chair of Harvard's astronomy department, and head of the Galileo project, published his initial assessment of 3I Atlas. He introduced what he called the Loeb classification scale for interstellar objects. The scale runs from 0 to 10. 0 means a completely natural object, a comet or asteroid from another star system, behaving exactly as physics would predict. 10 means confirmed alien technology posing a major threat to humanity. When 3I Atlas was first discovered, Loeb gave it a 4 out of 10. That is not a fringe position. That is a measured, calibrated scientific assessment from one of the most credentialed astrophysicists in the world, saying that this object displayed enough unusual features to warrant serious consideration of non-natural explanations. By March 2026, after months of data collection, Loeb revised that score down slightly to a 3 out of 10. Not because the anomalies went away, but because the object's cometary behavior, the gas release, the dust, the water, was confirmed, making a purely natural explanation more plausible than it had initially seemed. A 3 out of 10 still means this object has unexplained features that a natural comet does not easily account for. And that is where the scientific debate lives. One of the most striking things about 3I Atlas is not what it is made of. It is the path it took. And the path it took is, statistically speaking, almost impossible to explain by chance. Our solar system is laid out like a flat disk. The sun sits in the middle. All the planets orbit in roughly the same plane, what astronomers call the ecliptic plane. If you were looking at the solar system from the side, it would look like a thin, flat plate with the sun at the center. Now, if a random object from deep space tumbles into our solar system, you would expect it to come in at a steep angle. Random objects from random directions do not naturally align with the flat plane of someone else's solar system. The Milky Way galaxy itself is tilted about 60 degrees relative to the ecliptic plane. So, a truly random interstellar object should on average come in at a significant angle to the ecliptic. 3I Atlas came in tilted just 5 degrees off the ecliptic plane. 5 degrees, nearly perfectly aligned with the orbital plane of every planet in our solar system. Loeb and his colleagues calculated the probability of that happening by pure chance. 0.2%. 1 in 500. But the alignment was only the beginning. On its way through the solar system, 3I Atlas made close approaches to multiple planets. It passed within about 29 million miles of Mars in early October 2025. It reached perihelion, its closest point to the Sun, on October 29, 2025, at a distance of about 1.36 astronomical units, or roughly 126 million miles from the Sun. And it made its closest approach to Jupiter in mid-March 2026, passing within about 33 million miles of the gas giant, right at the edge of Jupiter's Hill radius, the zone where Jupiter's gravity dominates over the Sun's. The combined probability of a random interstellar object arriving at that precise angle and making close approaches to 3 major planets? Loeb's team calculated it at roughly 0.005%, 1 in 20,000. And then there is the timing. When 3I Atlas reached perihelion, its closest and most critical point to the Sun, the moment when the most important physical activity would be happening, Earth was on the exact opposite side of the Sun. We could not observe it at all. Every ground-based telescope on Earth was blinded by solar glare at the precise moment when 3I Atlas was at its most active and most interesting. If you were designing a spacecraft to conduct operations without being observed from Earth, you could not have timed that better. Loeb called this a potential reverse solar Oberth maneuver, a reference to a real rocket science technique where you use a close pass to a massive object to change your speed and direction efficiently. Whether that interpretation is correct or not, the timing is a documented fact. The Jupiter encounter deserves special attention. Jupiter's Hill radius, the distance at which Jupiter's gravity dominates over the Sun's tidal gravity, is approximately 33 million miles. The closest approach of 3I Atlas to Jupiter was calculated at 33.3 million miles. That is essentially identical to the Hill radius. The significance of that match is this. Any object deposited inside Jupiter's Hill radius, given the right velocity adjustment, could remain in a gravitationally stable orbit around Jupiter indefinitely. Any object deposited outside that radius would eventually be pulled away by the Sun's gravity. 3I Atlas passed right at the boundary. Loeb pointed out that if 3I Atlas were carrying technological devices intended to be deployed as artificial satellites of Jupiter, the Hill radius boundary would be the optimal release point. Objects released just inside that boundary, with a small velocity adjustment, could settle into stable orbits around Jupiter, potentially at the Lagrange points, where orbital corrections require minimal fuel. That is a remarkable coincidence. Or it is not a coincidence at all. Now, we get to the feature of 3I Atlas that has generated the most scientific debate. The jets. Normal comets have tails. Those tails point away from the Sun, pushed by solar radiation pressure and the solar wind. The tail is always on the side of the comet facing away from the Sun, regardless of which direction the comet is moving. 3I Atlas had a tail, but it also had something else. It had a prominent jet pointing toward the Sun, in the opposite direction from a normal cometary tail. This is called an anti-tail. Anti-tails are not completely unknown in solar system comets. They can sometimes appear as a perspective effect. When Earth is in the plane of the comet's orbit, the tail can appear to point toward the Sun due to the viewing angle. But the anti-tail of 3I Atlas was not a perspective effect. Analysis of the Hubble Space Telescope image from July 21st, 2025 showed that the anti-tail before perihelion was a physically real collimated jet pointing toward the Sun, about 10 times longer than it was wide. No known comet has ever exhibited a physical sunward jet of that length that is not a perspective effect. And after perihelion, the anti-tail continued, now pointing toward the Sun from the other side, as 3I Atlas moved away. The fact that a collimated jet appeared as the sunward anti-tail both before and after perihelion, while reversing direction at perihelion relative to the direction of motion, has a tiny probability of occurring at random. Loeb calculated that probability at about 1 in 40,000. But the anti-tail was only part of the jet story. The Hubble Space Telescope captured detailed images of 3I Atlas, showing 3 distinct mini-jets shooting out from its nucleus. Those 3 jets were spaced almost exactly 120 degrees apart from each other. Equal spacing, like 3 points on a perfect triangle. Loeb and his colleague Tony Scarmato published a paper analyzing these jets in detail. They found that the jet structure wobbled periodically, rotating around the object's axis with a period of 7.1 hours. The wobble is consistent with a rotating system where the jets are misaligned with the rotation axis, like a spinning top that is slightly off balance. And the 3 jets appeared persistently in Hubble images taken on multiple dates between November 30th, 2025 and January 14th, 2026. This is not a one-time observation. It is a consistent, repeating pattern. Natural comets do not produce equally spaced jets. Natural comets vent gas and dust randomly wherever the ice happens to be, wherever sunlight hits the surface. The result is always uneven and unpredictable. Equal 120-degree spacing suggests something deliberate. Loeb's colleague Dr. Frank Lokian noted that 3 equally spaced thrusters in the plane perpendicular to a rotation axis would be the minimum viable configuration for controlling the orientation of a rotating object in 3-dimensional space. In other words, if you were designing a propulsion system for a rotating spacecraft, 3 thrusters spaced 120 degrees apart, plus 1 main thruster along the rotation axis, would be a logical engineering choice. That is exactly what 3I Atlas appears to have. 3 mini-jets at 120 degree spacing, plus 1 major anti-tail jet along the rotation axis. 4 jets total. Geometrically arranged in a way that makes engineering sense. Here is another jet anomaly that does not get enough attention. The base of the post-perihelion anti-tail jet, the one pointing toward the sun after perihelion, was on the night side of 3I Atlas before perihelion. And the base of the pre-perihelion anti-tail jet is now on the night side of 3I Atlas after perihelion. For these jet bases to be active only when facing the sun, they would need to be well insulated on the night side for a period longer than several months. In a natural comet, heat flows by conduction throughout the body of the object. The night side warms up over time. You cannot maintain a sharp temperature difference between the sunlit side and the dark side for months on end. But that is exactly what the jet geometry of 3I Atlas requires. Either the object has an unusually effective insulation system, something not seen in any known comet, or the jets are not driven by solar heating at all. And here is one more jet anomaly that Loeb highlighted. When 3I Atlas passed perihelion, the sun's gravity deflected its path by approximately 16 degrees. That is a significant change in direction, and 16 degrees is exactly twice the opening angle of the anti-tail jet, which was observed to span about 8 degrees out to a distance of roughly 1 million kilometers. That means if one edge of the jet cone overlapped with the sunward direction before perihelion, then the other edge of an identical jet cone on the opposite pole would overlap with the sunward direction after perihelion. In other words, the geometry of the gravitational deflection at perihelion is perfectly matched to allow the same jet system to produce a sunward anti-tail both before and after perihelion, just switching from one pole to the other. The probability of that geometric match occurring by chance is extremely small. It is either a remarkable coincidence, or it is not a coincidence at all. One of the most technically important anomalies of 3I Atlas is its non-gravitational acceleration. This is the fact that the object is not following a purely gravitational path. When astronomers track a comet, they calculate where it should be based purely on gravity, the gravitational pull of the sun and the planets. If the comet is exactly where the calculation says it should be, its motion is purely gravitational. If it is slightly off, if it is ahead of or behind where gravity alone would put it, then something else is pushing it. For normal comets, that something else is outgassing. When a comet vents gas, the gas pushes back on the comet like a rocket exhaust. This is called the rocket effect, and it produces a small but measurable deviation from the purely gravitational path. 3I Atlas showed a non-gravitational acceleration. That by itself is not unusual for an active comet. What was unusual was the direction of that acceleration. NASA's official analysis initially reported that the non-gravitational acceleration of 3I Atlas was primarily radial, directed away from the sun. That is what you would expect from simple outgassing driven by solar heating. The sun heats the sunward side of the comet, gas vents away from the sun, and the reaction pushes the comet away from the sun. But a new paper published in March 2026, a comprehensive analysis by Spada, Krolikovska, and Donez, found something different. Their analysis showed that the radial and tangential components of the non-gravitational acceleration were similar in magnitude. In other words, 3I Atlas was being pushed sideways, perpendicular to the sun object line, almost as much as it was being pushed away from the sun. That is not what simple solar-driven outgassing produces. Simple outgassing pushes you away from the sun. It does not push you sideways. To produce a significant sideways acceleration, you need jets that are not pointing directly away from the sun. You need jets that are pointing in other directions. Like, for example, 3 jets spaced 120 degrees apart in the plane perpendicular to the rotation axis. The non-gravitational acceleration data and the jet geometry data are consistent with each other. And neither of them is consistent with simple, uniform outgassing from a natural comet. Here is a detail that Loeb found significant. After he published his paper noting that the Périhove distance of 3I Atlas, its closest approach to Jupiter, was essentially identical to Jupiter's Hill radius, he emailed David Farnokia at NASA's Jet Propulsion Laboratory to point out the coincidence. He received no response. But within a couple of days, the non-gravitational acceleration model on NASA's JPL Horizons website was revised. The new model used a different mathematical formula for how the acceleration varies with distance from the sun. Under the new model, the predicted Périhove distance shifted slightly from inside Jupiter's Hill radius to just outside it. Loeb noted that the new model was likely inadequate because it did not account for the steep brightening of 3I Atlas near perihelion, which suggested a much more concentrated burst of activity close to the sun than the new model predicted. He also noted that the insistence of NASA officials on a particular model would not change the actual trajectory of 3I Atlas, just as the Vatican's insistence on Earth being at the center of the solar system did not change Earth's orbit. The actual trajectory would be determined by the data. And the data, as of March 2026, still showed a Périhove distance remarkably close to Jupiter's Hill radius. One of the most fundamental anomalies of 3I Atlas is one that does not get much attention in popular coverage. It is called the mass budget problem. And it is, in some ways, the most scientifically damaging anomaly of all. Here is the issue in plain language. If 3I Atlas is a natural interstellar comet, a fragment from a planetary system around another star, then there must be a source population of similar objects large enough to explain how often we detect them. In other words, if we detected 3I Atlas, there must be enough similar objects in interstellar space that one of them passing through our solar system is not a once-in-a-billion-years event. Scientists can estimate the size of that source population based on the size of 3I Atlas and the detection rate. And when they do that calculation for 3I Atlas with its estimated nucleus diameter of 2.6 kilometers, or roughly 1.6 miles, the required source population is enormous. Larger than what the known mass reservoirs of planetary disks around low metallicity stars can plausibly produce. In simple terms, there may not be enough rocky material in the right kind of star systems to produce enough 3I Atlas-sized objects to explain why we are seeing one now. The mass budget does not add up. The mass budget problem has two possible resolutions. The first is that our models of planetary disk mass are wrong, that there is more material in interstellar space than we currently think. The second is that 3I Atlas is not a random sample from a large population of natural interstellar objects. It is something else, something that was specifically directed toward our solar system, rather than drawn at random from a reservoir of interstellar debris. Loeb has argued for the second interpretation. He points out that if 3I Atlas targeted the inner solar system, if its trajectory was planned rather than random, then the mass budget problem disappears. You do not need a huge population of similar objects if this one was sent deliberately. That is a significant logical step, and it is one that most mainstream astronomers are not willing to take. But the mass budget problem itself is real, documented, and published in peer-reviewed papers. It has not been resolved. This is the anomaly that most scientists treat as a coincidence. But it is worth understanding what the coincidence actually is. On August 15, 1977, a radio telescope at Ohio State University detected an unusual signal from space. The signal lasted 72 seconds, the maximum time the telescope could observe any given point in the sky as Earth rotated. It was so unusual that the astronomer who noticed it in the data printout wrote the word "wow" in the margin. The signal has never been explained. It has never been detected again. It came from the direction of the constellation Sagittarius, and it had characteristics consistent with what scientists would expect from a deliberate transmission from an extraterrestrial civilization. 3I Atlas arrived from a direction coincident with the WOW signal to within 9 degrees. Loeb was the first to point out this coincidence in a paper published shortly after the discovery of 3I Atlas. He calculated the probability of a random interstellar object arriving from within 9 degrees of the WOW signal direction at roughly 0.6%. That is not a proof of anything. A 0.6% probability means it could easily be a coincidence, but it is one more data point in a list of data points that keeps getting longer. And Loeb raised an interesting possibility. What if the WOW signal was not a transmission from a distant civilization? what if it was a transmission from a companion device to 3I Atlas, or from the civilization that sent 3I Atlas, announcing its arrival nearly 50 years in advance? That is speculative. Loeb acknowledges it is speculative. But attempts to detect radio transmissions from 3I Atlas toward Earth on specific dates during the past several months have been made. So far, none have been detected. Here is one of the more technical anomalies, but it is worth understanding because it is one of the clearest signs that 3I Atlas is physically different from known comets. When light from the sun hits the dust and gas around a comet, it scatters. And the way it scatters, the direction in which the light waves vibrate after scattering, is called polarization. Scientists measure the polarization of light from comets to learn about the physical properties of the dust, the size of the particles, their shape, their composition, and the structure of the coma. Different types of dust produce different polarization signatures, and 3I Atlas produced a polarization signature that has never been seen before. 3I Atlas showed extreme negative polarization, unprecedented for all known comets, including 2I Borisov. Most comets show positive polarization at the angles where 3I Atlas was observed. The extreme negative polarization of 3I Atlas suggests that the dust particles around it are physically different from the dust particles around any known comet. They may be larger, they may have a different structure, they may be made of different material. The antitail of 3I Atlas extends at least 400,000 miles in length. For a jet of particles to extend that far without being stopped by solar radiation pressure, the particles need to be significantly larger than normal cometary dust. Normal cometary dust particles are smaller than the wavelength of visible light, less than about 0.0002 inches across. Solar radiation pressure stops particles that small very effectively. But to extend 400,000 miles, the particles in 3I Atlas's antitail need to be at least 100 times larger than typical cometary dust. And larger particles scatter light differently, which is consistent with the unusual polarization signature. As 3I Atlas moved toward perihelion, its brightness increased. That is normal for comets. As they get closer to the sun, they heat up, vent more gas and dust, and reflect more sunlight. But the rate at which 3I Atlas brightened was not normal. Inside 2 astronomical units from the sun, roughly twice the Earth-Sun distance, the brightness of 3I Atlas increased nearly twice as fast as the steepest normal cometary brightening rate. That suggests something unusual was happening as it got close to the sun, a sudden, dramatic increase in activity that went far beyond what simple solar heating would produce. And it was also bluer than the sun near perihelion. A blue color in a cometary coma is the signature of specific gas emissions, fluorescence from carbon monoxide and amide radicals. It suggests that as 3I Atlas plunged toward perihelion, it shed its outer layers and began releasing volatile gases from deep inside. The real object, the blue, violently outgassing engine inside, only revealed itself when it got close enough to the sun. After perihelion, the Spherex Space Observatory and the James Webb Space Telescope detected a rich suite of organic molecules in the gas plume around 3I Atlas. These included methanol, formaldehyde, methane, ethane, water, carbon dioxide, and carbon monoxide. The production rate of organic molecules was about 14% of the water molecular production rate. And the water production rate itself had increased by a factor of roughly 20 compared with pre-perihelion observations. These organic molecules are known biosignatures, molecules associated with biological processes on Earth. That does not mean 3I Atlas is carrying life, but it does mean it is carrying the chemical building blocks that life uses. And Loeb raised a question that is worth sitting with. If a civilization wanted to spread life to other star systems, to act as what he called an interstellar gardener, one way to do it would be to deposit microbes inside a natural interstellar object, along with nutrients and a power source. The object would carry the package across the galaxy for free. When it entered the habitable zone of another star system, the package would deploy. 3I Atlas has the water. It has the organics. It has the carbon compounds. It has everything you would need to sustain a biological payload on a long interstellar journey. Whether it is actually carrying anything biological is a question that cannot be answered from Earth. It would require a sample return mission, landing on 3I Atlas and bringing material back. That mission was never launched, and 3I Atlas is now heading back out into interstellar space. The geometry of 3I Atlas is striking, but the chemistry is where the story gets genuinely strange. Because what scientists found in the gas and dust surrounding this object does not match anything in our solar system. Let's start with water, because water is the most fundamental thing scientists look for in a comet. The James Webb Space Telescope detected water around 3I Atlas after perihelion. That is not surprising. Most comets contain water ice, but the amount was extraordinary. The Solar and Heliospheric Observatory, known as SOHO, detected a massive cloud of hydrogen surrounding 3I Atlas after perihelion. Scientists calculated that in just 1 month of observation, this object released approximately 13.5 million metric tons of water. That is an enormous amount. But the water itself was unusual. Studies of the deuterium to hydrogen ratio in the water around 3I Atlas found a value of about 0.95%. That is more than 10 times higher than what has been measured in known comets. Deuterium is a heavier form of hydrogen. The ratio of deuterium to normal hydrogen in a molecule is a chemical fingerprint. It tells you about the temperature and environment where that molecule formed. Very high deuterium ratios point to formation in extremely cold environments. And the deuterium ratio in 3I Atlas's water is so high that it points to a formation environment far colder and far more unusual than anything that produced the comets in our solar system. Then came the methane. The James Webb Space Telescope detected methane in the gas plume around 3I Atlas after perihelion. That by itself was interesting. Methane is a biosignature, one of the molecules associated with biological processes on Earth. But the timing of its appearance was puzzling. Methane ice is more volatile than carbon dioxide ice. That means it sublimates, goes from solid to gas at lower temperatures. You would expect methane to appear in the gas plume before carbon dioxide, but that is not what happened. Carbon dioxide and carbon monoxide were detected in the gas plume around 3I Atlas long before methane appeared. Methane only showed up after perihelion, after the object had made its closest approach to the sun and was already moving away. That sequence is backwards from what simple models predict. It suggests that the methane was buried deep inside 3I Atlas, protected from solar heating by layers of other material, and only became exposed after the outer layers were stripped away near perihelion. And the deuterium ratio in the methane was even more extreme than in the water. A paper published in March 2026 found a deuterium to hydrogen ratio in the methane of about 3.31%. That is 3 orders of magnitude higher than methane found on planets in our solar system. It is about 14 times higher than the methane deuterium ratio measured in Comet 67P by the Rosetta spacecraft. That is not a small anomaly. That is a chemical signature so unusual that it points to a formation environment unlike anything in our solar system, possibly a region of the early Milky Way that was extremely cold and extremely old. Before perihelion, the gas plume surrounding 3I Atlas contained something that genuinely surprised scientists: nickel. Specifically, a very high ratio of nickel to iron. In industrially produced nickel alloys, the kind used in aerospace engineering and high-temperature applications, nickel is deliberately concentrated relative to iron to achieve specific material properties. The nickel-to-iron ratio in 3I Atlas's gas plume was orders of magnitude higher than what has been found in thousands of known comets, including 2I Borisov. And the nickel-to-cyanide ratio was also far outside the normal range for comets. Scientists do not have a simple natural explanation for why an interstellar comet would have this particular chemical signature. A team using the ALMA radio array in Chile measured chemicals in the coma of 3I Atlas and found methanol along with hydrogen cyanide. The surprise was not that methanol was there. The surprise was how much of it there was compared with hydrogen cyanide. They found methanol to HCN ratios of about 70 on one date and about 120 on another. That is far higher than what scientists typically see in comets from our own solar system. And the methanol appeared to be coming not just from the nucleus of the object, but also from ice particles in the coma surrounding it, suggesting the methanol is deeply built into the material of 3I Atlas, not just the surface coating. The isotope work on carbon in 3I Atlas also came back unusual. The carbon isotope ratios were higher than the values typically found in the solar system, nearby interstellar clouds, and protoplanetary disks. That pushes the same message as the deuterium results. This object is chemically out of family with the material around us. And, taken together, the extreme deuterium in water, the extreme deuterium in methane, the unusual nickel ratios, the high methanol, the unusual carbon isotopes, the chemical picture of 3I Atlas, points to a formation environment that was colder, older, and more foreign than anything that produced the objects in our solar system. Some researchers interpret this as evidence that 3I Atlas formed 10 to 12 billion years ago, more than twice the age of our solar system, in a region of the early Milky Way with very different chemistry. Now, let's be straight about what all of this means, because this is where the story requires intellectual honesty. The majority of astronomers who have studied 3I Atlas believe it is a natural interstellar comet. Their position is reasonable and evidence-based. 3I Atlas shows cometary activity, gas release, dust, water, organics. These are the signatures of a natural icy body heating up near a star. The non-gravitational acceleration is consistent with outgassing, the same rocket effect seen in solar system comets. The jets, while unusual in their geometry, could potentially be explained by localized pockets of ice on the surface of the nucleus. The unusual chemistry, the high deuterium, the unusual nickel ratios, the high methanol, could reflect the unusual formation environment of an ancient, low metallicity star system. The trajectory alignment with the ecliptic plane, while statistically improbable, is not impossible. Unlikely things happen. This is a reasonable position, and it may be correct. Loeb's position is more nuanced than the headlines suggest. He is not claiming that 3I Atlas is definitely alien technology. He is claiming that the combination of 22 anomalies, each individually explainable, but collectively very difficult to dismiss as coincidence, warrants serious scientific investigation of non-natural explanations. He is also claiming that the mass budget problem, the fact that the source population required to explain 3I Atlas may not exist, is a genuine scientific problem that has not been resolved. And he is claiming that the scientific community's reflexive dismissal of non-natural explanations without seriously engaging with the data is a failure of scientific rigor. That is a defensible position. Science is supposed to follow the evidence wherever it leads. And the evidence from 3I Atlas leads to some uncomfortable places. 3I Atlas is fading now. It passed Jupiter in mid-March 2026 and is heading back out into interstellar space toward the Gemini constellation at over 130,000 miles per hour. In a few months, it will be too faint to observe from Earth. But the scientific work is far from over. The James Webb Space Telescope data from the post-perihelion observations is still being analyzed. The ALMA radio array data on the methanol and hydrogen cyanide is still being processed. The isotope studies on the deuterium ratios are still being refined. The directional and velocity analysis of the March 2026 fireball events to determine whether any of them could be fragments from 3I Atlas has not been completed. And the ESA's JUICE spacecraft, which photographed 3I Atlas in November 2025 from a distance of about 41 million miles, is still processing its spectral data. There is a lot of science still to be done. The Vera C. Rubin Observatory in Chile began full operations in 2025. It is expected to detect dozens of interstellar objects per year once it reaches full capability. That means the scientific community will have many more opportunities to study interstellar visitors. And the framework developed for 3I Atlas, the Loeb classification scale, the mass budget analysis, the jet geometry analysis, the isotope fingerprinting will be applied to every future interstellar object. 3I Atlas has changed how scientists think about interstellar visitors. Whatever its true nature, it has forced the development of new analytical tools and new scientific questions. Here is the part of this story that is genuinely frustrating. When 3I Atlas was first detected on July 1st, 2025, it was still months away from its closest approach to Earth. There was time, not much, but some, to design and launch an interceptor spacecraft. A spacecraft launched immediately after discovery could have been designed to cross the forecasted path of 3I Atlas at its closest approach to Earth on December 19th, 2025. It could have taken close-up photographs. It could have collected a sample. It could have answered definitively whether 3I Atlas is a natural comet or something else. That mission was never launched. The scientific community debated. The space agencies evaluated, the window closed, and 3I Atlas passed Earth's closest approach point without a single spacecraft to meet it. Loeb has been direct about this. He called it a missed opportunity, one of the most significant missed opportunities in the history of space exploration. And he has argued that the scientific community needs to develop a standing capability to intercept interstellar objects, a network of spacecraft ready to launch on short notice when the next visitor arrives. Because the next one is coming. The Rubin Observatory will find it, and when it does, we will have a choice. Watch it from a distance and wonder. Or go meet it. Here is the truth about 3I Atlas. It is the largest, fastest, and most chemically complex interstellar object ever detected passing through our solar system. It has 22 documented anomalies, each individually explainable, collectively very difficult to dismiss. Its trajectory had a 1 in 20,000 probability of occurring by chance. Its chemistry does not match anything in our solar system. Its jets are geometrically arranged in a way that makes engineering sense. Its non-gravitational acceleration has a significant sideways component that simple outgassing does not easily explain. Its mass budget creates a serious problem for the standard model of interstellar object populations. And it passed behind the sun, completely out of our view, at the single most critical moment of its journey. The mainstream scientific community says it is a natural interstellar comet from an ancient low metallicity star system. That may be correct. A.V. Loeb says the combination of anomalies warrants serious consideration of non-natural explanations, and that the scientific community's dismissal of those explanations without engaging with the data is a failure of rigor. That may also be correct. What is certain is this. 3I Atlas has changed the conversation about interstellar objects. It has forced scientists to ask questions they had never needed to ask before. It has revealed gaps in our models that need to be filled. And it has demonstrated beyond any reasonable doubt that the universe is more complex, more surprising, and more interesting than our current models account for. Whether 3I Atlas is a natural comet, a Trojan horse, or something we do not yet have a category for, it has already done something remarkable. It has made us look up. And it has made us ask, seriously and scientifically, whether we are alone. That question does not go away when 3I Atlas fades from view. It gets louder. Pay attention. If this documentary got you thinking, subscribe to Space Aquarius so you do not miss what comes next as the data keeps coming in. Leave a comment and tell me where you stand. Natural comet, something stranger, or something we do not have a name for yet. Every comment gets read, and if this one changed how you think about what is out there, share it with someone who needs to see it. The story of 3I Atlas is not over. It is just beginning.